Hello coders, I welcome you all. In this video, we are going to discuss RAG, Retrieval Augmented Generation. We will also try to implement RAG from scratch in a very simple way. First, we will discuss the idea behind RAG, and at the end, we will summarize the entire RAG process. So make sure to watch this video till the end to understand how RAG works. If you don't fully understand some parts on the first watch, I recommend watching it one more time. I'm sure by the end, you will have a very clear understanding of RAG. So let's get started. Large language models, LLMs like ChatGPT, Gemini or Claude are trained on huge amounts of public data like books, websites, Wikipedia. But they have two big limitations. First, they don't know recent events like yesterday's exam announcement. Second, they can't access your private means internal data like your college latest syllables, your company's HR policies, or hospital's visitor guidelines. Likewise, so these are two big limitations of LLMs. Now, first, let's take a real world problem. Imagine you are a student asking what is the minimum attendance required to sit for exam. The model might say most colleges require 75% attendance, but maybe your college recently updated the rule to 80%. Why is the model wrong? Because it was never trained on your college internal rulebook, right? But what if we add the right context? So now suppose you provide the actual policy document to LLM that says students must have 80% attendance to be eligible for final exams. Now, if you ask to LLM what's the attendance rule, the model answers correctly because we have provided the actual policy document that says students must have 80% attendance to be eligible for final exams that we already provided to LLM. So now again, if you ask what's the attendance rule, the model answers correctly. You need 80% attendance as per your college policy. This is called augmented generation. We improved the answer by adding real context. So now the question is, how do we find the right document automatically? Let's say your system has 100 PDFs of college policies, circulars, and notices. You can't copy, paste them every time someone asks a question, right? So you need a way to automatically retrieve the most relevant document. This is where the retrieval part of RAG comes in. Now, before we move forward, let's discuss about embeddings, how the AI understands text. Embedding is equal to a numerical representation of a text. Please remember this. Embedding is a numerical representation of a text. We use an embedding model to convert each document and user's questions into a list of numbers called vectors. Don't you worry, we will discuss this practically and you will understand at the end what are embedding models. But now please listen it carefully. I am repeating, we use an embedding model to convert each document and the user's question into a list of numbers called vectors. These vectors represent the meaning of the text. Similar meanings means vectors that are closer together in space. Different meanings means vectors that are far apart. Hope all of you are clear with embeddings, which is a numerical representation of a text. Now let's move on. Now the question is how to find the most similar document, also called as similarity search. Once everything is in vector form, we compare the user's question vector to all document vectors, which is called as similarity search, to find the closest match. This search is often done using cosine similarity. It measures how aligned the meanings are. The document with the highest similarity score is the most relevant to the question. Before we move forward, let's discuss vector store. Please remember, if you only have 2-3 documents, you can store the vectors of that document in memory, like a pandas data frame. But if you have hundreds or thousands of documents, you need a vector store, a system designed to store vectors efficiently. Perform fast similarity search. These are some of the examples of vector store: FISS, Pinecone, ChromaDB, etc. So please remember, you don't need to worry about this unless you are working on large scale systems. We can use pandas data frame as a vector store if we are working on 2-3 documents, right? Hope all of you are clear with vector store. Now let's move on. Now we have found the most relevant document. We combine it with the question. Here is the example. Document. Students must maintain 80% attendance, which is mentioned in our one of the document. Also, we can consider this as a context. And here is our question. What is the attendance rule? So we combine this document with this particular question and we are sending question plus document to LLM. Now the LLM reads both the question and the document. Document means context. This document provides context to our LLM. As we discussed, now the LLM reads both the question and the document and gives a correct personalized answer. This is called RAG, Retrieval Augmented Generation. Hope all of you are clear with this, right? How RAG works. Now, before we move forward, let's understand meaning of each part of RAG, Retrieval Augmented Generation. So let's start with R, retrieval. This is the step where the system searches for relevant information from stored documents. Next, A, augmented. This means we add, also called as augment, that retrieved document as context to the question before giving it to the large language model. Next, G, generation. Finally, the large language model like ChatGPT or Gemini generates the answer using both your original question and the retrieved augmented document as context. Hope all of you are clear with RAG. Now, let's understand full RAG workflow. First, user asks a question. All documents are already embedded into vectors and are available inside vector store. Question which is asked by user is also embedded into a vector. Now next, similarity search is done between question and document vectors. Hope all of you are clear with this, right? Document vectors are available inside vector store. Now most relevant document is selected. After that, we are combining document with question. After that, we are sending both document and question to LLM. Now LLM generates a correct context-based answer because we have provided document as a context. So RAG helps LLM answer smarter by automatically searching the most relevant document, combining it with the question and generating an answer based on real facts. No guesses. This is the exact idea behind RAG, Retrieval Augmented Generation. Now let's revise one more time through this particular animation. Now let's summarize entire RAG process. First, user asks a question. Let's say, what is the vacation policy? Now, instead of directly sending this question to Gemini or any other large language model, we take a smarter route. We first send the query asked by the user to an embedding model. This model doesn't just keep the text. It converts the question into a vector, which is a basically mathematical representation of the meaning behind the sentence. At this point, now we have two things. First, the original query in plain text and its vector form, which captures the deeper meaning of the query. Now, here is the important part. Let's assume that earlier we have already taken all our documents like HR policies, PDF files, or internal manuals and converted each of them into vectors in the similar way. Means similar way as we have followed for user question. Now all of our vectorized documents are stored in what we call a vector store. So this is our vector store. Now just imagine we have a big collection of documents, each represented by a vector that reflects its meaning. Now comes the key step. We compare the user's query vector with all the document vectors in my vector store. This comparison is done using a method called cosine similarity. Think of it like measuring how close two arrows are pointing in space. Now, whichever document vector is closest to the query vector, that's likely the document that matches the user's intent. So we pull out the matching document, but please remember, we don't need its vector anymore. I need the original text of the document. Now I take the user's original question and add this relevant document text as context that we have fetched to vector store and converted back vector to text and fetch relevant document from here, from our documents. Hope all of you are clear with this, right? So I'm repeating, we pull out the matching document, but as I said, we don't need its vector anymore. We need the original text of the document. Now we take the user's original question and add this relevant document text as context. After that, we are sending both user's question and his context to LLM, and LLM will generate answer based on this context. No any guesses, right? Because we have already provided context with user's query. Means we have provided question with background information. Now, when LLM answers the question, it's not just guessing based on general knowledge. It's giving a response based on real relevant documents from inside the company. That's the core idea of RAG, Retrieval Augmented Generation. It helps model give grounded, trustworthy answers, especially when you want it to work with your private data, not just public internet data. Hope all of you are clear with RAG. If you don't fully understand some parts on the first watch, I recommend watching it one more time. And I'm sure by the end, you will have a very clear understanding of RAG. Now let's walk through a complete end-to-end example of RAG, Retrieval Augmented Generation, using a real-life academic use case. Specifically, how a chatbot can answer questions about college attendance policy. We will simulate this using the ChatGPT chat window that you can see on the screen. No programming, no database, just a practical demonstration of how RAG works in the simplest way possible. But before we implement RAG, let's check the default behavior of ChatGPT. Imagine a student asks ChatGPT this particular question: what is the minimum attendance required to sit for final exam at ABC Engineering College? So here we are checking behavior of ChatGPT before RAG. Let's press this, and here you can see it is searching the web, and it found this information. You can see. So since ChatGPT is trained on older public data and doesn't have access to our internal college policies, it replies like this. You can see at least 75% attendance in each course, right? However, ABC Engineering College has recently updated its policy to 80%. So the model's answer is outdated and incorrect. This happens because ChatGPT has no way of knowing about recent internal updates unless we explicitly provide that information. So we will follow the standard RAG workflow. We will create a knowledge base, means document for our internal policy. Next, retrieve relevant documents. After that, we create a context-rich prompt. After, generate a response using LLM's large language model. Right now, let's back to ChatGPT chat window. As we discussed, we will simulate this using ChatGPT, just as you might do with real internal college documents. First step, create the knowledge base, means our internal policy document. So let's begin by creating our knowledge base that I have already created for you. So in this demo, we are using a Word document. So this is Word document that we are going to use as a knowledge based. You can see ABC Engineering College Attendance Policy 2025. And here you can see minimum attendance requirement. All students must maintain a minimum of 80% attendance in each subject to be eligible to appear for final examinations and other. You can see. And this policy effective from this particular date that you can see. Right? So this is our knowledge base. In this demo, we are going to use this particular document as a knowledge base. So this document contains our internal rulebook that you can see here. So this is the kind of internal data that ChatGPT normally doesn't have access to unless we provide it, right? So now let's back to ChatGPT chat window. So now let's upload our document, our policy document. So here I will click this particular icon plus and add photo and files. And you can see this is our policy document. Let's click over here and let's click open. Done. So please remember, here we are simulating the retrieval step by manually uploading the document into the LLM. Now let's create the user query. So here I am asking same question as we asked earlier to check the default behavior of ChatGPT. What is the minimum attendance required to sit for final exams at ABC. Let's click over here. As you can see over here, perfect answer. Without the document, ChatGPT might guess based on general knowledge, something like usually 75% that you can see. But now that we have augmented the prompt with our actual document, this particular document, and you can see ChatGPT can give a fact-based answer that you can see over here. And as you can see, the LLM correctly answers 80% attendance in each subject is mandatory to be eligible for final examinations that you can see over here. So this proves that the response was generated with context from our uploaded document. You can compare default behavior of ChatGPT and after uploading our policy document of our engineering college that you can see. And here you can see this simple demo shows how RAG works in Excel. We retrieve a real document, attendance policy. We augmented the query with the content that you can see. We augmented this particular query with our document, with our policy. The LLM generated a context-aware factual answer that you can see over here, all using nothing more than the ChatGPT interface that you can see here. So please remember, RAG is powerful because it bridges the gap between generic knowledge and our own data, whether it's college rules, HR documents, hospital procedures, or technical manuals. Hope all of you are clear with RAG and how RAG works. So we will try to implement RAG from scratch in a very simple way in the next video. Hope all of you are clear with this. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video where we are going to implement RAG from scratch in a very simple way.